Okay, so welcome back. So for this part, I want to talk about how we can show how atoms are connected to different atoms in a covalent molecule. So we have many types of molecules here. We have ClO3, that's chlorate ion, water, and then carbon tetrachloride. No, so this one is used in alam mo yung hostage. Tapos tatakpan ng towel yung ilong. Tapos hihimatayin ka. So ito yan, CCl4. Anyway, so what I want to share with you is how we can make all this. Because as I mentioned in the previous video, even though we have few nonmetal atoms, they can be combined in such a way that we can make life out of it. No? So now our task is to show how different atoms can be combined in a molecule. So the best way to show that the molecules are connected with another is by its Lewis structures. So again, you have to remember the name. It's Gilbert Lewis who created all this stuff in order to explain how molecules are bonded to each other. So in the Lewis structure, we can see here that you have atoms surrounded by other atoms. Then you have bonds connecting them. So for example, this is a double bond. This one is a double bond. This is a single bond. Single bond, single bond, single bond, single bond, single bond, da, da, da. Okay, so those are single bonds. You also have this pair of electrons that are not bonded. So we call them lone pairs. Okay. By the way, let me do the dissection of the Lewis structure. So these are the bonds. Okay. So these are the bonds. It may vary from single, double, triple bond. Then you have the unshared electrons. Remember, you need two electrons to be shared, but if they are not used, we call them lone pairs. And then as you can see here, you have an atom in which all other molecules are connected. For example, in this molecule here, which atom connects all the other atoms? Of course, the answer is Cl. For this one, that is oxygen. For this one, that is carbon. So the atom that connects all other atoms, we call them the central atoms. Okay, so these are called central atoms. And the one that is connected to the central atom, we call them terminal atoms. Okay. So here's the next slide. I forgot na naka-label na pala. So we have four parts in a Lewis structure. You have the central atom, in which all other atoms are connected with. You have the terminal atoms, in which all other atoms are connected to the central atom. So sorry. You have the lone pairs and the bonds. Okay. So those are the parts of the Lewis structure. Now, let us identify what makes a central atom a central atom. Okay, so a central atom is the atom in your molecule that that is the least electronegative. Okay, and the terminal atom should be the most electronegative. Okay, so why is it that the central atom needs to be less electronegative than the terminal? Because remember that atoms will pull the electrons. Okay, so if you have a central atom that is more electronegative, so that may not be possible because it will not uh it will not pull the electrons towards the center, no? Kumbaga, it will just pull the electrons far off from each other. So you cannot have a more electronegative atom to be in the center. Okay? That's not possible. And the terminal atom should be the most electronegative atom. Why? Because um, it will pull the electrons of the lesser electronegative atom, making the bond possible. Okay? Parang ganon. Okay. So the lone pairs, remember, kanina when we draw molecules, there are dots, pairs of dots that are not used in bonding. So that means they are just there. Okay. So they are not used for chemical bonding. They're just roaming around. Those are called lone pairs. Lone in a sense that they do not get paired with other atoms. So how can we make Lewis structures? So these are the steps. I will just shortly flash them on screen so you can take a screenshot. Although I have a different approach than this one. Okay. And then I'll show you my process. Okay. So in your worksheet, I told you to follow the NASU rule when you draw molecules. Okay. But before we go there, let us draw some basic molecules muna. Okay. So for example, let's have carbon dioxide as our demo molecule. So carbon dioxide is the one that we exhale. It is also the primary reason for the global warming that we are experiencing right now. All industrial processes produces CO2, and then they go up in the atmosphere. They absorb the heat from the sun, and then it heats up the world, as we know. So how will we draw the CO2 molecule? So before you do anything else, you have first to decide which is the central atom and which is the terminal atom. So we're talking about electronegativities. So in the periodic table, let me just pull up a periodic table. Okay, so this is our periodic table. The electronegativity trend increases from the bottom left part to the top upper right hand corner of the periodic table. So meaning fluorine is the most electronegative atom of all. So it also increases from left to right. Okay. So that means boron is less electronegative than carbon, which is less electronegative than nitrogen, which is less electronegative than oxygen, and which is less electronegative than fluorine. Okay? So parang ganon. Pag going up naman, it's also increasing. That means tellurium is less electronegative than selenium, which is less electronegative than sulfur, which is less electronegative than oxygen. So our atoms in CO2 are carbon and oxygen. I want to identify which is the central atom. So, based on the periodic trends, which is the central atom? Of course, I slipped. Carbon yun. Okay. Carbon will be the central atom because it is less electronegative than the oxygen. Okay. So let's go back to our whiteboard. So we just identified that carbon is the central atom and oxygen will be our terminal atom. because of their electronegativity. So after identifying which is which, you can now draw the skeleton. So let's draw the skeleton. So how do you do skeleton? You just put the central atom in the middle and then put the terminal atoms around that central atom. So of course, I cannot do it this way. Hindi pwede yan. Because if we have this pattern, the oxygen will be the central atom. So what I will do instead is to write it this way. Oko. Okay, so in such way, we ensure that the carbon is in the middle. So we identify the central atom and the terminal atom. We created the skeleton in which the central atom is in the middle. Now let us show the NASU rule. So the NASU rule is a shortcut actually, but it's very versatile. So let me just break down the NASU rule. N is the needed electrons. A is the available electrons. S is the shared electrons. And then U is the unshared electrons. So when we create bonds, whether that's ionic or covalent, there's a necessity for us to get the octet rule with exemption to hydrogen, okay? And metals. Metals don't need electrons. Hydrogen doesn't need 8, but the rest needs 8 electrons. So basically, when I say needed electrons, I'm just pertaining if the atom needs octet. Okay? So let's break it down. No? So for carbon, does it need octet? Yes, because it is in the p orbital or the p block of the periodic table. If you are wondering what is a p block, so let me just remind you again that this is the S block, the P block, the D block, and the F block. Any atoms that are in the P block will require octet rule. So let's go back to our whiteboard. So carbon is in the P block. Therefore, it needs octet. So we'll put 8 electrons that's needed by carbon. Then we have oxygen, but I will put times 2 because there are 2 oxygen atoms. Do you think oxygen needs octet? Yes, because it is also in the same block, the P block. So I will write it as 8 times 2 because we have 2 oxygen atoms. So I will just add this up. So 8 plus 8 times 2, so it's same as 8 times 3, 24. Okay. Now, let's talk about the available electrons. The available electrons here are just your valence electrons or the group number. Okay? So which group number does carbon belong? Carbon belongs in group number 4. Oxygen belongs to group number 6. So it has 6 valence electrons. But remember, we have 2 oxygen atoms, so you need to multiply this by 2. So 6 times 2 is 12 plus 4. Ilan yan? 16. So 16 electrons available. So in a sense, what we are doing here is a bit of math, but the idea is this. We needed 24 atoms in order for everything to work out. But we only have 16 electrons. Now, it is our task to make sure that these 16 electrons from all these atoms are well taken care of. Na? So we'll find a way to make sure that these 16 electrons may follow the octet rule. Na? Okay? Ito lang kasi available. Kailangan 24. So we need to find a way in which we make these 16 electrons work. So, paano yun? We go to the shared. So, the shared is the number of needed minus available. Okay? And it will tell us about the number of bonds. Okay? So needed, we have 24 electrons minus available, we have 16. So 24 minus 16 is 8. Tama ba? 8. Tama naman. 8 nga. Sorry. So we have 8 electrons to be shared between those atoms. How many bonds are that? Remember, there are 2 electrons for every bond. So we have 4 bonds here. How about unshared? So unshared electrons are going to be our lone pairs. Okay. So the formula here is that it should be available minus the shared, A minus S. So you have 16 minus 8. So that will be 8 electrons. How many electrons are there in a lone pair? Pair yung term. So we have 2 electrons per lone pair. So that means we have 4 lone pairs. So that means in the molecule of CO2, we need to have 4 bonds and 4 lone pairs to be distributed. Yun na yan. Then we can draw a molecule out of this. Now, let me draw 4 bonds. I can do it this way. Okay, so tigdo double bond doon, left and the right. Or pwede rin naman ganito. Okay, so I can do it this way. Pwedeng ganyan, tig-dalawa. Pwedeng 3 dito, 1 doon. Pero hindi pwede yung 4 dito, wala doon ha. That's impossible. And always remember, at the end of each line of each bonds, you have electrons. So I will use a colored ink for that one to represent that for each line you have 2 electrons. For each bond, you have 2 electrons. Ayan. Ayan. So let me focus on this one. Focus ako dito ha. So, here's the thing. The molecule is almost complete, but I still have to show the lone pairs. Okay, so I already have given the bonds, so the atoms are connected now. Now my problem is, how will I distribute the lone pairs? I have 4 lone pairs. So the rule here is to give the terminal atoms the lone pair first. So sa terminal muna. So this is the terminal atom, oxygen. How many electrons are surrounding oxygen? So there are 4 electrons surrounding oxygen. Eh di ba kailangan octet, 8. So where can I get those extra electrons? I can get them from the lone pairs, right? No. So I will use a different color for that one. Maybe I'll have violet na lang. So I will use how many lone pairs pala? You have 4 electrons here. You still need 4 more. So how many lone pairs is that? You need 2 lone pairs. Ayun. That's correct. Yan. And if we count it again, does it follow the octet rule? So we have 1, 2, 3, 4, 5, 6, 7, 8. It is already octet. Now, let's focus on the other terminal atom here. You have 4 electrons here. You still need 4 more, which comes in 2 lone pairs. 2 more lone pairs. Okay? And then you're done. Okay? How about the carbon? We already consumed all the unshared electrons. Apat na yung lone pairs dito. 1, 2, 3, 4. We already used up all the lone pairs. Okay, so let's count if we need more for the carbon. Does it follow the octet? Yes. Octet na siya. So, kumbaga, there's no need for more lone pairs. So this is the structure of CO2. And we're actually done with this. Now, let us try the other one. So for this one, I have this thing and that thing. I have 4 bonds. I need to distribute the lone pairs. So let me focus here first. I'm sorry. Yeah. So for this oxygen, I have 6 electrons already. And then I needed 2 more, which will come in the form of 1 lone pair. So this one is already octet. On the other hand, this has only 2 electrons around it. So I needed 6 more, which comes in the form of 3 lone pairs. Yeah. So is it octet? Yes, it's already octet. Now, we consumed all lone pairs. How about the carbon here? It's already octet because it has 8 electrons around it. So we're done. But here's the problem. The problem is, which of the 2 structures is correct? No. Is it this one? Is it the A or the B? And that is the next video. Okay? So stay tuned.